Hey everyone, in this video we're going to be talking about logarithmic functions, what they are, what they look like, and why we need logarithmic functions. Let's begin by solving for the inverse function. So, we are given just a simple function, f of x is equal to 2 to the power of x. Well, we know that this will have an inverse function, as when graphed, it is simply an exponential function. Therefore, since it passes the horizontal line test, we know that this function must have an inverse. So let's find that now. Well, we can interchange x and y, but wait, what do we do here? How do we rearrange for y? Up until this point, we have never had to solve for a variable in the exponent position, so what do we do? Well, to unpackage this exponential function, we must use something called a logarithm. Logarithms are the inverse of exponential functions, and give us a way to bring our exponent down and solve for it. So, how do we do this, you may ask? Well, we can write this equation in logarithm notation, which doesn't actually change anything, it just gives us a way to solve for our variable y in the exponent position. We can say that these two equations are equivalent, just one is in logarithmic form, and the other is in exponential form, but they are identical. Just note that there are a few restrictions to this. Firstly, we do not do this if our base is equal to 1, as it doesn't really matter what 1 is raised to, as it'll always return 1. Secondly, we do not put equations into logarithmic form if we have a negative base. The reasoning for this is that it leads to a non-continuous functions, and isn't really all that helpful. Let's just spend a bit of time now and practice solving some logarithms, to ensure that you understand. So, if we are given log 16 to the base 2, what is this equal to? Well, remember this is asking us to solve for what exponent can our base 2 be raised to get to 16? Well, that's 4. 2 times 2 times 2 times 2 is 16. What about this one? We have the natural base e to 1. Well, there are two things that I want to mention here. Since the natural base e is so common, we have another equivalent way of writing this, which is ln, or the natural logarithm. So, writing log base e, or ln, are the exact same thing. Now, back to our problem. We know that any base raised to the power of 0 is 1. Therefore, our value is 1. So, now that we have an idea of what logarithmic functions are, and what they are used for, what do they look like graphically? Well, as I stated earlier, they are just the inverse functions of exponential functions. So, if we have 2 to the power of x, we can create a table of inputs to outputs. So, let's just do this from 0 to 5. This results in the following output table. Then, as we talked about in a previous video, to graph inverse functions, all we need to do is switch the input and output of our original function. Therefore, we get the following values. Now, we can just plot both of these functions on the graph. As you can see here, when we draw a line along our x equals y line, these two functions are indeed the inverse of each other. In the next video, we'll be talking more about the laws of logarithms, so how you can manipulate your logarithms mathematically. Thank you for checking out this video, and I hope it helped your understanding of what logarithmic functions are and what they look like. If you enjoyed, please like, subscribe, and consider checking out our Patreon page to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.